Book 80 Head Robot Project. Book 80 Head Robot Project. This book is valuable in Brazilian editor Club dos Autores. Sorocaba, Brazil 2020. Biography. Caicon Ricardo Paes Marcino de Almeida, born in the city of Apa, located in the state of São Paulo, Brazil. He is currently majoring in information technology management. He has some experience in the industrial automation area, where he has already worked as an operator of an automated station for treatment and disposal of lathes waste. Has technical courses in C# programming language, but did not work on software development in a professional way, being an amateur in areas such as electronics, robotics, and even in music, where he plays violin, piano. Sorocaba 2020. Abstract. Again, I've been gathering my ideas. Forgive my inability to write. Head transplant surgery. As in any experiment, resources are needed. In the case of this experiment, which we could call cut head, in English cut head, or better there is a complexity in the conduct and cost of the operation. One way to implement this experience would be to use a quadriplegic patient, and only his head or neurological set would be removed and inserted into an individual who had brain death. A major problem in this experiment would be to adapt body to head. Lasers would cut and join the vital parts to life support systems, and would slowly remove the entire body from the head and then join a temporary system, and at the same time do this to the other body. Then after completing the procedures, the two parts would be joined. Initially it would be a surgery that could be done initially on human type animals like monkeys. Electronic modulation would cheapen the process initially, because, given that errors could occur and there would be a high mortality rate. Head transplant surgery. The surgery could be done gradually, initially only by cutting blood vessels and inserting actuators of substances, even considering that the study would generate information on how to keep the brain active with the minimum of vital substances, as in the case of living in space or in accidents critical in which it needs to operate, and to know which are the vital points of the brain. And then the criticality would be increased by removing the head completely from the individual and replacing it again. In cases where there is a lack of a vital component such as oxygen in the brain, surgery could be undertaken that would cut the channels connected to the oxygenation of the brain and join with an intermediate coupling that would bring, for example, oxygenated blood to the brain. Electronic simulation. After obtaining the input/output data, you can simulate the experiment in special simulation software and feed databases with this data, and then transfer this data to an electronic system initially. So it would be interesting to draw a board that would simulate the head with generation of alpha waves, fluid outlets, etc. Then you can go on to the real experiment that would be a solid base where the individual's head is inserted and can then be connected to other elements of a robotic body, for example, and thus generating a base for further studies as a fully impact-resistant body, etc. This step in the study was intended to build systems that would support a live guinea pig's head. One possibility would be to create a coupling between the first system, that would be the head, and the second, that would be the body, and this intermediate coupling could already be inserted in patients under study in order to analyze the functioning and the adaptation of the body to the process. The intermediate ring coupling. After obtaining a robotic system that simulates the head and body of the guinea pig, which could be larger in size as a human being, a device similar to a choker can be designed using ultrasound. Infrared would study the guinea pig and replace vital functions until it is complete surgery possible. Usual guinea pig. You can start the experiment with a brainwave receiver, from where you can study how the brain controls the limbs of the body, receiving control and processing it to move a robotic arm, for example. It would be interesting if you use the same usual guinea pig in the experiment, because your brain would be used to external control. In cases where back-learning software is used, a virtual model can be used, and even use a mouse to adapt a brainwave reader that could be internal or external to the individual. And by inserting the guinea pig in a controlled environment where you have access to variable parameters such as food, stimulating the guinea pig to control these accesses and processing its outputs, you can design an experiment where the guinea pig generates an entry like a mini cart connected to a mat, and when walking would guide the cart to the food, and adapting this control to a robotic leg would generate movement. One need would be to make the coupler from head to body the same size as the individual and mixer of substances. Control software for robot head. You can initially use buttons to access the voice emission to test the functions. Control by computer. You can use the relay control by computer with sound cards and C# commands such as beep. Positioning sensor and end sensor can be designed course that start. Control software for robot head. You can initially use buttons to access the voice emission to test the functions. Control by computer. You can use the relay control by computer with sound cards and C# commands such as beep. Positioning sensor and end sensor can be designed course that starts a motor that activates a key monitored by the system, while the movement can be guided when listening to the sound of the computer and starting the motors manually. Electronic board. Designing a plate that would simulate the head with the generation of alpha waves, fluid outlets, etc. Then you can go on to the real experiment that would be a solid base where the individual's head is inserted and can then be connected to other elements of a robotic body, for example, and thus creating the basis for new studies such as a body totally resistant to impacts, etc. This step in the study was intended to build systems that would support a live guinea pig's head. One possibility would be to create a coupling between the first system that would be the head and the second that would be the body, and this intermediate coupling could already be inserted in patients under study in order to analyze the functioning and adaptation of the body to the process. Head Robot Research Project. Draw arms on the side so that the camera sees manipulation. To increase mobility. Low mat trolley or RC wheels. Lace up legs. Station surgery to train precise movements. Home motor generator set. cabeça robo project. Head. Use paint pot. Arduino car proj. By clear reception. Car AV screen. Modem with Wi-Fi. PIC project. Robotics. Develop technical devices emulation. Use CI arm simulate Skynet reader. Adapt reader outputs to program. Draw Sheldon robot. PC monitor. Webcam motor fan. By desk place. Use cell control to keep changing. List robot tasks. Leave scheduled. Answer gate. Washing dishes, etc. Record video based on screen rest. Electronics. Design an easy circuit to program other boards such as Arduino, Blue Pill, and Raspberry Pi with ready-made programs with various examples and online connection. You can download new programs and then transfer them to the ARM programmer, with minimal resources, 32 bits, etc. LCD keyboard or even Bluetooth. Initially, an Arduino can be used to program another Arduino and make it easier. Draw a Blue Pill adapter plate on the Arduino.